Have you ever wondered what makes up an aircraft? Well, you're in for an enlightening journey. An aircraft is a marvel of engineering, a complex union of multiple components, each playing a crucial role in its operation. The main components that we'll be exploring in this series include the fuselage, that's the main body of the aircraft, the wings that keep it aloft, the tail assembly for stability and control, the controls that allow pilots to maneuver the aircraft, the landing gear for smooth takeoffs and landings, and last but not least, the engine and propeller that provide the necessary thrust for flight. Each of these components is a world in itself, a testament to human ingenuity and the relentless pursuit of conquering the skies. So, prepare to embark on an exciting journey into the world of aviation. Stay with us to dive deeper into each of these components, starting with the fuselage. The fuselage, often considered the backbone of the aircraft, plays a pivotal role in aviation. As the central body, it's designed to accommodate the crew, passengers, and cargo. But it's more than just a container. It's a marvel of engineering that brings together the strength needed to withstand the rigors of flight, and the lightweight design crucial for efficient air travel. The fuselage is a testament to the balance between durability and weight, a key factor in aviation. It's built from materials carefully chosen for their strength-to-weight ratio, resistance to flammability, and long-term mechanical and chemical stability. The fuselage's construction also considers ease of manufacture and cost-effectiveness, demonstrating how every element in aviation is a result of careful decision-making. The fuselage's design and construction reflect the complexity and elegance of aviation technology. It's a stark reminder of how far we've come in our quest to conquer the skies. Moving on from the fuselage, we come to the wings. Wings are a vital component that gives an aircraft its unique ability to fly. The wing's primary function is to generate lift, a force that opposes gravity and allows the aircraft to ascend. Lift is produced as air flows over the wings, creating a pressure differential between the top and bottom surfaces. But not all wings are created equal. There are various wing designs, each with its own set of characteristics. For instance, straight wings, common in slower aircraft, offer high lift and stability. Swept wings, on the other hand, seen in fast jets, reduce drag at high speeds. Finally, we have delta wings, often spotted on supersonic aircraft, which provide a large surface area for lift and stability at high speeds. The choice of wing design is, therefore, a balancing act between lift, speed, and stability. From the wings, let's journey to the tail assembly. At the back of the aircraft, we find the tail assembly, an essential part of the aircraft's stability. This assembly is comprised of two main parts, the vertical stabilizer, or the fin, and the horizontal stabilizer. The vertical stabilizer prevents side-to-side or yawing motion of the aircraft's nose. Attached to the rear of the vertical stabilizer is the rudder, the movable part that controls yaw. The horizontal stabilizer, on the other hand, prevents an up and down or pitching motion of the aircraft's nose. At the back of the horizontal stabilizer, there's the elevator, which controls pitch. Together, these components play a pivotal role in controlling the aircraft's movement and maintaining its balance. Whether it's making a routine turn or correcting a sudden shift caused by turbulence, the tail assembly ensures the aircraft can smoothly and safely reach its destination. Having discussed the tail assembly, we now move to the controls. Controls and landing gear, two diverse but equally crucial components of an aircraft. The controls, consisting of the yoke or stick, rudder pedals, and throttle, are the pilot's primary tools for directing the aircraft. The yoke or stick controls the ailerons and the elevator, allowing the pilot to maneuver the aircraft in the lateral and vertical directions. The rudder pedals enable the pilot to steer the aircraft on the ground and to make coordinated turns in flight. The landing gear, on the other hand, is an essential component that provides a stable platform for the aircraft during takeoff, landing, and while on the ground. It absorbs the shocks and stresses of landing and allows the aircraft to be maneuvered on the ground. These components, though distinct in function, are integral to the operation of the aircraft, each playing its part in ensuring a safe and controlled flight. Finally, we arrive at the heart of the aircraft, the engine and propeller. The engine and propeller, the driving force of an aircraft. The engine's role is to generate thrust, essential for the plane to move forward. It does this by drawing in air, compressing it, mixing it with fuel, and igniting the mixture. This process results in a forceful expulsion of hot gases from the back of the engine, propelling the aircraft forward. The propeller, on the other hand, is a type of fan that transmits power by converting rotational motion into thrust. Simply put, when the engine turns the propeller blades, it moves air past the blades and generates lift. There are various types of aircraft engines, including the piston engine, the turbojet, the turboprop, and the turbofan, each with its own characteristics and applications. From small piston engines propelling light aircraft to massive jet engines driving commercial airliners, the engine and propeller are integral to the magic of flight. This brings us to the end of our journey through the components of an aircraft. We've taken a deep dive into the fascinating world of aircraft components. We started with the fuselage, the aircraft's backbone, housing passengers, cargo, and most of the aircraft's equipment. The wings, those majestic structures, provide the essential lift, while the tail assembly ensures stability and control. We've examined the controls, the pilot's main interface with the aircraft, and the landing gear, crucial for taking off and landing. We also explored the heart of the aircraft, the engine and propeller, responsible for thrust and motion. Each component, from fuselage to propeller, has a unique role, working in harmony to make aviation possible. They are the result of countless hours of engineering, design, and testing, all aimed at ensuring safety, efficiency, and performance. Next time you see an aircraft, you'll be able to appreciate the complexity and engineering marvel that it is.